All right. Good afternoon, everyone. We'll get started. Um, okay, so quick logistics thing. On Canvas, I put all the files from the code that we do in class. So if you ever miss anything, you can look there, as I mentioned before. I also, for all of our lectures, include like PDF notes. And so this is our kind of lecture one material. So this kind of gives a walkthrough of what we covered as well. So both of those resources, just know that they're available on the Canvas files. Okay. Any questions about that or any of the material from lecture one? No? Okay. So we're just going to continue on our tutorial today. And the first thing that I wanted to talk about is logical operators. And so we actually kind of looked at this a little bit in our function example. Probably should have covered this before we did that, but we're here now. So, okay, so let me assign and create this object x, defining it as 6. So a logical operator is a test on whether essentially a value meets a certain type of criteria, right? And so I can check, for example, x equals 6. Okay, and so this is a logical operator to see whether or not the object that I'm testing on the left-hand side matches the thing on the right-hand side. And so if we enter this, this is true. Pretty intuitive. The one thing that I'll note here is that, like, far and away the most common, like, minor coding error that people make is interchanging one equal sign with two equal signs, right? And so one equal sign is an assignment operator, and typically we don't use that for default assignment operators, but it might be assigning a value in like a function, for example, a function input. So the most common mistake is accidentally using one equal sign here. Just know that that's a easy thing to check. Okay. We can see what happens if I do a logical operator where the values don't match, and we see that indeed it's false. Okay, so essentially equals equals is asking if these things are matching, and we can also have an operator that asks what happens if, to test whether if they don't match, right? And the syntax for that is exclamation mark equals. It's meant to kind of represent like a slash through your equals sign, right? Okay, and so this is asking, do these values not match? And so what do you guys think is going to be the answer here? False, right? Does x not equal 6? X is equal to 6, and so this statement is false. But if I do the same thing for a different value, it'll end up true, right? So you're just inverting those. We also have logical operators that can test if things are bigger or smaller. Okay, so is x larger than 6? No, right? That's false. You can do greater than or equal to 6, in which case this would be true. And you can also test less than as well. So is x less than 7? Is 6 less than 7? Answer is true. Okay, pretty straightforward so far. Any questions about that? Okay. Let's see here. The next thing we can look at are logics for ands and ors. And the way that you do this, so there's some combination of trues and falses that I can do. And this is meant to do combinations of conditionals. Okay. So let's see. I think this is kind of intuitive in the sort of English language. So without thinking necessarily about the code, let me ask you guys some questions. So am I wearing hat and socks? True or false? False, right? Because I would have to be wearing both of them to be, for that statement to be true. But if I were to say, am I wearing a hat or socks, then that would be true, right? So that's the kind of logic that we're following here. So for ands, true and true is true. True and false is false, right? So hat and socks is false. And that can be in either order. And then obviously false and false is false. Yeah, so this is logic testing. And I can also do ors, which is the vertical line. So that's the shift/key. So true or true, true or false, false or true, and false or false. And this follows our logic. If there's one true in the statement, in the or logical statement, then it's going to be true. It's only if both items are false that it's false. Okay. That intuition just takes a little bit of practice to get used to. But I would say this is probably one of the more common procedures that you guys would do both in this class and in coding in general. So it's something useful to get good practice on. All right. Any questions? Yes.
That line is or.
Yeah, so let me make a little note for you here. So so the and symbol is and then the vertical line symbol is or. On Macs, it's the key in between your return and delete. I think it's the same on Windows keyboards as well. Okay. Moving on. Now we're going to talk about data types. All right, so what data types have we already encountered? So this is a number. Okay. Pretty straightforward. I entered this as a new object. I've assigned it the number 1. And in fact, our allows us to test data type categories just to make sure that that we're dealing with the right thing. So is numeric. This is a number. So is.numeric is the function that tests whether an object follows the criteria type. And so if I hit enter, it will return true because indeed the object that we created is a number. And I'm saying number. The proper terminology in R, they call this data type numeric data type. All right. There's actually kind of a different number type called an integer. And the way that we assign that integer specification is with a capital L following the number. Okay, oop. I did not write out integer all the way. Okay, so let me ask you guys this. So is.integer, this is an integer. True or false? True. Great. All right. Without checking, is integer. Tell me what you guys think. So I'm going to put in to the function, this is a number. So that's our first one, not our second one, right? Without the L. So is this is a number, an integer, the number one. What do you guys think? Raise your hand for true, and raise your hand for false. A couple of people. All right, you guys are like tied. And there's a bunch of you who don't want to answer. That's all right. And the answer is false, okay? It looks like an integer, but it's not actually an integer unless you explicitly specify the L. To be honest, we will not be dealing with integers much, but it might come up as a data category if you're like using certain data sets and you're like wondering why certain operations might be working or might not be working. This could be a reason why. And so, yeah, if weird things are happening, it might be good to check whether or not you've got something categorized as an integer or numeric and vice versa. What about the other way? Is numeric, this is an integer? What do you guys think? Does the integer count as a numeric category? I see someone saying no, I see someone saying yes. It is, okay? And so integers are subsets of the numeric category. So all integers are numbers, but not all numbers are integers. Okay. We also have character types. So this is dot character. Okay, and that says that's true. Great. For those of you who are more versed in Python, characters are just strings, essentially. And a little bit more testing is dot character. If I put in the number 1, false. But if I put quotes around it, it's true. And likewise, is dot numeric. If I put quotes around the number, then it's false. Oh, you'll notice me using single versus double quotations. They are interchangeable, as in the quotes themselves will essentially specify that you're using a character, and you can use them in pairs interchangeably. And so it could be high or high like this, but you cannot do, a single quote and then ending with a double quote. They have to be paired. That does come in handy sometimes if you want to have strings that have like quotes inside of them. So if I wanted to write something like Amy says hi, I can do this. Or conversely this, right? And that will capture within the string the quotation marks without ending the string, without being in a designator to end the character. Okay? So here. Okay. Yeah, so you can put quotes inside of quotes if you interchange them. One kind of quick note, I guess I didn't mention this last time. If you want to put comments in your code to kind of like just make notes or something like what I'm doing here, where I'm saying you can put quotes inside of quotes, or up here where I'm saying, oh, we're looking at data types. So this is called a comment, and that's just a line of code that doesn't run. And the way that you specify that you are making a comment is with the pound or hashtag symbol. Okay? All right, any questions so far as we're going through data types? Okay, we have also just looked at logical data types. So true. So is dot logical, this is a logical. So logicals are trues and falses. In R, we actually can shortcut as well. So if you don't feel like typing out true, a capital T specifies true, and that still works. And same with capital F. So is logical false is true, not to be confused, right? That we're testing a condition, we're just seeing whether or not that particular item is true or false, and it is, so therefore it returns true, even if the item itself is false. Okay. There's one last data type. 5 imaginary points to anyone who knows this last data type. Any ideas? Okay, it's one that I guarantee you we won't use in this class, and unless you're a math major, you're probably not going to use it either. These are complex numbers, like imaginary numbers, right? But just to be thorough and complete, this is kind of what that looks like. So if you take the square root of a negative number, right, it's the square root times I, or plus 1i. And that is texted by this function is.complex. And so same thing as we've been doing before, and that's probably the first time you guys have seen this, and will also be the last time that we see this in this class. Okay. All right, any questions about data types? In general, being pretty grounded and understanding what these data types are is kind of an easy way to understand your data and make sure you're not making weird mistakes, right? We're mainly going to be dealing with numbers, numerics, characters, and logicals in this class. And sometimes these things can get intermingled, especially in dirty data sets. So it's always something to watch out for if things are not working in the way that you expect. One of the first things you can do is to check the data types. Okay? We also have data structures. So let's talk about vectors. We have already seen a couple examples of vectors before, right? So vector 1, I'm going to define as 1, 2, 3, 4. And we've seen in the previous class some examples of things that we were doing with vectors. Okay, so again, without looking, is dot numeric vector 1? All right, are vectors numeric? So raise your hand if you think the answer is true. Okay, and raise your hand if you think false. Okay. So, drum roll, true. So vectors can in fact be numeric. And we will get back to this as a concept in just a moment. When I have objects that contain multiple elements, I can also pull out those elements by referencing an index number that points to which element, where that element is in that object, right? And so the way that in R that we do references to point to indices is with square brackets. So I have an object that contains multiple elements, and if I want to examine inside of this object a particular element, I'm going to put a square brackets after that object, and I'm going to just put the position that I'm interested in looking at. Okay, so if I wanted to look at position 3, I would say vector 1 bracket 3, and that's going to return, in this case, 3. The numbers are the same as the elements. It doesn't have to be, right? So if I said test 4 through 9, something like this, and I wanted to return the element in the second position, what do you think would get returned? Yeah, 5, I see. Right, so hit enter, and it returns 5. Okay, so pretty straightforward. Okay, so now let's create a different vector. We'll do something a little bit different. I'm going to create a vector that contains elements A, B, C, D, which, right, I have quotes around each of these, which means I'm setting them as characters. So is character vector 2? Without running, what do you guys think? True or false? Raise your hand for true, and raise your hand for false. Okay. Okay, we have one false. Sorry, I'm not trying to trick you here yet. it is actually still true. And so a vector can be numeric, and it could also be a character, depending on what's contained in the inside of that vector. Okay. So, and obviously, this is maybe a little silly to look at. Is dot numeric vector 2 false? And I can do the same thing. Vector 2, I want to look at position 1. That's going to return the letter A, because A is in the first position of my vector. Pretty straightforward so far. So now, let's get a little trickier. Okay. Vector 3 defined as 1, 2, and then the characters A and B. And now, is dot character. Okay, so who thinks this is both a number and a character? Raise your hand. Who thinks it's a number but not a character? Raise your hand. Who thinks it's a character but not a number? Raise your hand. And who thinks it's neither? Okay. Drum roll. Vector not found. Didn't define it yet. All right, new drum roll. It's not a number, but it is a character. Ooh, okay. So what's going on here? Let's take a closer look. Okay, so let me type in vector 1, 1, 2, 3, 4, vector 2, A, B, C, D, vector 3, 1, 2, A, B. But what is interesting about vector 3? What's different? They're all in quotation marks, right? And the quotes are indicating that we are in character territory, okay? So why does it do this? Well, can A or B, all right, can A or B be a number? No. Can 1 or 2 be a character? Yes. So characters will supersede numbers when you are presenting them together. And so this is, I want to say, the number one thing that trips people up when we're working with data. Let's say you're importing a big data set, and one of the columns you think is a number data set, and it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. And then somewhere, someone fat fingered a key, and there's like a letter in there. When you import that data, all of that is going to get imported as a character, right? Because the vector of that column doesn't know how to deal with that random letter inside of that vector. So it just turns it all into characters. And then you try to do some kind of like math operation on it, and it doesn't work. This is, I want to say, the number one issue that we run into when we're doing like data parsing and analysis and that sort of thing. Okay? Any questions about this? Great. Yeah, and so the key takeaway here is that vectors can actually have data types, but they can only have one data type. They cannot contain elements of different data types, because that entire vector has to be characterized as one data type. And if it doesn't know what to do, by default, it will almost always turn it into a character, because characters are the most flexible. Okay. So let's talk about matrices and arrays. So it's actually fairly straightforward. All the rules that I was just mentioning about vectors kind of apply to matrices and arrays as well. The only difference is that, yeah, actually, does anyone know what a matrix and / or an array is relative to a vector? So an array is simply a two-dimensional vector, or sorry, a matrix is a two-dimensional vector and an array is an n-dimensional vector. So let's take a look at an example of this. So matrix 1 is something like this. Let's just do 1, 2, 3, 4. And here I have to specify the number of rows and number of columns. And let me inspect my matrix. And it looks something like this. Okay, so 1, 2, 3, 4. You have 2 rows and 2 columns as I sort of specified out. Okay. If I want to reference a particular element inside of the matrix, we can do this in much the same way as we did with the vectors, where I need to point based on an index. Except now I have 2 indices. I have a row index and a column index. And the rule in R is row, then column. It's always row and then column. You can see that reflected actually in the matrix itself. So RC is just something that you have to memorize in terms of order. So if I wanted to return the element equal to 2, how would I do that? What was that? 1, 2. That returns the number 3, not the number 2. So remember, row, then column. So the number 2 in my matrix is in the position. We can see here on the screen, it's in the second row, first column. So you would do 2, 1. Okay? So run that, and that gives me 2. And we can, yes?
What if I don't put the column number? Like if it's just...
Okay, yes. So what happens if I do, matrix 1, 2, column like this?
No.
Oh, the other way.
Just one value, like, I don't know.
Oh, if you do this. What do you guys think?
It will assume the first column and give it to them.
It'll what?
Assume the first column and just give it that. It will take the first row.
What?
And then assume you're going for the first column.
Wait, you mean the second row?
Second row.
Yeah, okay. You're confusing me for a second. No, it's all good. Okay. Yeah, so do we think that it just assumes that you go with the first column? Is it going to give you a warning? Is it going to not work? Stay tuned to find out. Yeah, it actually will look at the second input. This is not a good practice to do this. So when you have multiple dimensions that you want to index and reference, don't make assumptions about what gets filled in as like a shortcut, because you could get into unintuitive territory. But yeah, so here it is assuming that it's just the second row and first column. What about this? Do you think this will give you the same answer? Yeah, so if I add the comma, it will return the entire row as a vector. Okay? And similarly, comma, let's say 2, it will return the entire column as a vector. Okay? So don't do this one. It's bad practice. Okay. Any questions about that? And we can do a quick check. Is numeric, and it's true. So follows along with the vector as I was mentioning before.
I have a question.
Yeah,
What if you wanted like multiple different, like let's say I wanted 1 and 4
sure.
from that. Is it like a comma, like you just separate it and like make a list, or?
So you want to return you want to return both this guy
Yeah.
and this guy. Okay. So I can do something like this, I think. Hold on. Can I do that? One comma one, and does this work? I don't know if I've ever tried this before. It's saying there's an X, so I'm scared to hit enter. Oh, matrix 1. I don't think that saves me. No. Multiple. How would I do that in a matrix? Okay, I'm gonna give you a shitty answer. Actually, that even won't work, huh? Now that I'm thinking about it. Or that. I can think of a really convoluted way of doing this, but I don't think that's kind of the right direction here. I may have to get back to you on that, unless someone else knows. Usually, when I'm doing like a multiple reference on like a lookup, that will actually be able to look at a couple examples we'll do later on today. What you're asking for is a little bit interesting because you're asking based on like index positions, which is not typically something that you would do, but I feel like I should know the answer to that. The more common one is we're going to be like looking up, you're trying to reference specific things based on like categories or filters in the rows and columns, and that there's kind of a more straightforward way of doing. Yeah.
Could you just do it by creating the vector with the indices and then running it for a loop with the vector?
Yes. Yes. Yep, you could do that.
It's long, but
Yeah, for index in actually even this is a little weird. I'm just gonna do this is such a cop-out way to do this. So let's see. Although actually, there's a nice little learning lesson to be had here. Yeah, this only works in a very specific case, obviously. But oh, yes, thank you. Yay, 1 and 4. Okay, so this is really a cop out, but actually the bigger lesson here is actually a little technique that's useful in for loops. If you want to grab an answer, if each iteration of the for loop is giving you part of an answer that you want, you can do this little trick here, which I'm showing. So I create a container for like, these are the answers that I'm gonna store my, or this is the container that I store my answers in. And then in here, you're gonna say, okay, take my container of answers and then add to it the answer that I want from the current instantiation of the for loop. So what it looks like here is output at the beginning is nothing. Then I go into the for loop, and then I look up this thing that we wanted, and that's the first element. You add it into the empty container, and then in the next loop, you add the next one into the container that has the first answer already. So this is like a very common programming trick if you guys haven't seen this before. Okay. Yeah, I'll get back to you on a better way of doing this. But we will talk about the more common way we look at this in just a moment. Yeah.
I think I found the shorter way. So
Yeah, okay.
yeah, C
Okay.
and parentheses and matrix 1 and 1 comma 1.
Oh. Yeah, okay. I guess you could do that. And yeah. Yes. So, this is to extract, like if you wanted to do it multiple times, and then you could do as many. I think what I was wondering is if within one like bracket search, you could do both at the same time. So I will still try and see if that's possible. Okay, any other challenging questions for me? All right, so the more generic version is just an array. So a matrix is a specific type of array. It's a 2D array. And a vector is, again, a type of array. It's a 1D array. We can think of this generically. So array, let's say I want to do the values 1 through 8. Then you can make the dimensions of your array kind of anything that you want. So I'm going to make a 2 by 2 by 2 array. And we can see what that looks like here. Array 1. And the answer looks something like this. So 1, 2, 3, 4 in the first, it's almost like you have back-to-back matrices. I'm kind of like thinking about this in 3D, right? And so in the first layer, I have in index position 1, 1, 1, it's 1, and so on. And then in the second slice, right, you have this two-dimensional 5, 6, 7, 8. Okay. So if I wanted to find the number 7 inside of my 2 by 2 by 2 array, how would I search for that? Who can help me out here? can follow the designations that you see in the like visualization of this array. Yeah. 1, 2, 2. Enter. Correct. So you can see the row comes first, then the column. Always going to look at the 2D slice first, row, column, and then it follows with however many slices that you make of this array next. So 1, 2, 2. Okay. Yeah.
Are these like two different arrays or?
No, it's one array, but it's in 3 dimensions, right? The way that the console visualizes that for you is it separates them out. It'll always give you slices in 2 dimensions, and then it'll just do these breakouts in the commas. So if you wanted to get more complicated, right, you could do something like array 1 through 12, where you have 4 dimensions, 2 by 2 by 2 by 2, and okay, and so this is good practice, right? So before I hit enter, see if you guys can visualize what this would look like. Wait, am I about to make a huge mistake? I think that, yeah, there's not enough. It's 1 to 16. Yeah. Okay, so the 3rd and 4th index positions are 1, 1, and then the first 2 index positions are displayed in 2D as rows and columns, right? So here's your first one, here's your first slice, and then second slice, referring to the first and second index position of 3, in position 3, first and second values in the 3rd index position, and then the first index value in the 4th position, and then 1, 2, and 2, 2 corresponding to these. So the first 2 positions of your array will always be displayed in this like 2D row column thing, and then after that it just specifies the position up here. Okay? Arrays are not so common for the types of work that we often will be doing, right? Most of it is going to be in like 2D structured data. So I wouldn't say this is something that you're going to run into that often, but still, I think it's in principle still good practice to understand how the like index positions work. Okay. Okay. Any questions about any of this? All right, so the next data structure we're going to look at is a list. And a list is not like a vector, matrix, or array. This is a generic data structure that it's just like the garbage can of R. You can just throw whatever you want into here. Okay, so I'm gonna define list 1 as the list of. All right, we're just gonna throw all of these things that we've made before into it. Vector 1, vector 2, vector 3. I'm going to throw in matrix 1 and array 1. They're just going to all go into this list. I'm going to hit enter, and now I have a list of 5 different objects inside of it. Okay. Is the list numeric? Nope. Is it a character? Nope. And is it a logical? No. Okay. It is just a generic container for all of these different objects. So what does it look like? list 1, I hit enter. Okay, and so the first element of the list, or the first object contained within the list, is our vector 1 object, which was 1, 2, 3, 4. The second object in our list was our vector 2, which is just A, B, C, D. Then vector 3, 1, 2, A, B. Then we had our matrix, 1, 2, 3, 4. And then we had our array. Okay? And so the way that I reference an object in the list is by pointing with these double square brackets. Oh, list 1, sorry. Okay, so the first object contained in list 1 was our 1, 2, 3, 4. In other words, vector 1. And you can chain the searches together. So this is essentially equivalent to, so this is equal to vector 1, right? It's actually identical to just typing out vector 1. So if I wanted to look up a particular element in that vector, I can follow it up by doing something like this, right? And that would be the third position of vector 1, which is the number 3. So how would I look up, let's say, the number 3 in matrix 1 out of our list? So what's object position is the matrix in? 4, right? And then inside of the matrix, what row and column is the number 3? You're used to the other way around. Yeah, 1, 2. So if I hit enter, it should be returning the number 3. Okay? Does everyone follow along, hopefully? Any questions about this? All right. Now, for everyone's favorite and most confusing data structure is the factors. Yeah, who loves factors in R? So, just to be clear, so those of you who have worked in R before, you've probably run into factors at some point. And factors, formally speaking, are a data structure and not a data type, even though that might be a little bit confusing, okay? So factor 1 so it looks like, so the start of this thing kind of looks like we're specifying it as a character. But there's kind of 2 arguments that you generally put into this factor function that is generating this particular data structure. And one is the vector of the inputs. That is this first thing that I input. And then the second part is this argument here where I'm specifying the levels of the input. Okay, so I'm going to go ahead and run this, and we're going to take a look at this. So what does a factor look like? Okay. So there's two kind of interesting things that you'll see when I hit enter. So one is below the vector that it's showing us, it gives us this weird thing that says levels, and those are the levels that I had specified in the argument. Okay, so it's showing us some extra information. What else is interesting about this output in the console that might not be intuitive? Anything? What's different about this compared to the characters?
I think it's claimed by alphabetical order.
Well, the levels are, I put them in alphabetical order, yes, but yeah.
There's no quotation marks.
Exactly, no quotation marks. Okay, that's a little weird, right? So, let's see. Is character factor 1? No, it is not a character. And there's no quotes, and so that should give you some alarm bells. And it is indeed a factor when I test that. So there's a separate test for whether or not it's a factor. Okay. So, what is a factor? So, a factor is a way of turning either numbers or characters into a particular data structure that you can do some kind of quantitative manipulations on. So, for example, for those who are familiar, if we're thinking about doing something as like a categorical variable, or you're looking at things that require certain things to be in a particular order, this is what designates that order. Okay. If I just had something like, A, B, C, D as characters, those inherently have no property of order unless you turn it into a factor and specify what that order should be. So we will come back to factors later on in the class and see in what ways they're actually kind of employed in certain functions and models and that sort of thing. But just know that characters and factors are not the same thing. And we can be very explicit about that too, right? So let's say, for example, I have my vector 1, right? We looked at this, vector 2. So A, B, C, D. Let's say I wanted to add in a couple of elements into my vector. I could do that, right? And it just tacks on extra things at the end. But if I wanted to tack on extra things to the end of my factor, well, I could do that, except that look at what happens. So my factor 1, which I thought was this is a factor, now turns into 4, 3, 1, 2, and then we've tacked on E and F to it, right? And so what is happening here? So 4, 3, 1, 2 is actually in reference to the position of the levels. Okay, I'm explaining this poorly. So we have pre-specified levels in our factor And so you think of this as the order of things that should be happening. And so this is the fourth order, should be in the, it's like the last thing in order. So this is in fourth position. And so this is 4, this one is 3, A is 1, and factor is 2, and it's just showing that positions. So when you're doing manipulations with factors, there's all sorts of weird things that can be happening like this if you're not careful. Okay, and in fact, even if we were to do something like, let's say I wanted to tack on E and F in here. The E and F become NAs, right? Because the program doesn't know how to deal with these elements that you're putting in because we haven't specified levels for them. So you're saying, okay, here's some stuff and it has to be, here's a dictionary for what order they should be in, and then you put in more stuff without changing the dictionary. It's gonna not know what to do with those, and so those turn into NAs, okay? So this is another area of like frequent error when you are doing data manipulation in R. If you're importing things and some of them are factors, you can get all sorts of aberrant behavior. And so just be cognizant of that as well. Okay. Any questions? Yeah.
What's the difference between using the double quotations versus like the single?
Nothing.
Okay.
They're interchangeable. R gives you the capability to do both so that if you want to put quotes inside of quotes, you can do that.
Okay.
Yeah. Yeah, I'll try to be consistent, but sometimes I just hold my finger down on the shift key. I usually use single quotes, so.
What's like an example of when you use a factor like in Go?
Yep.
Sure that.
Yeah, so if you have actually, this is a good time to we're going to talk about data frames, and I'm going to show an example of this kind of with, well, let me just do this really quick, and I'll show you an example. Okay, so you guys can copy this down while I talk here. All I've done is create a data frame. And I'll talk about what a data frame is in just a moment, but to answer your question specifically, if you're doing like a regression analysis and you have like you want to do regressions on like a categorical variable, in other words, if I have a non-numeric value, right? So in this particular case, let's say I wanted to assess the effect of like gender on test scores. Putting it as a factor is an indication to R that basically, treat all males as a certain way and treat females as a certain like category. If you think about this in terms of like characters, it wouldn't be something that it knows how to process. And actually the reasoning for this is, if you'll give me just a second, do I still have battery on this guy? Yes, okay. So let me show you what factors are kind of doing behind the scenes. All right. Oh no, are you serious? All right, sorry. We'll have to figure this out because that will be problematic for me. Yeah, all right. Thank you. Okay. If you have a table that looks something like this, so gender, so M, F, what's happening behind the scenes is so then I have, let's say I have other categories, so column 2, column 3, column 4. Essentially, what's happening behind the scenes in this factor is it's transforming this into a column M and a column F, and then all of your other stuff is still here. So C2, C3, C4, and it's doing something like this: 1, 1, 0, and 0, 0, 1. You don't see any of this, but this is what's happening kind of behind the scenes for when you're creating factors. Right, and so it makes sense when you're adding things that don't have specified categories, it doesn't know what to do with it. Okay. Anything else? Any other questions about factors? Okay. Oh yeah.
Could you just clarify what exactly the levels do again? So that has to do with the order, but then here it's kind of in reverse.
Yeah. So sorry. So up here, the levels also will specify order. And so there are other types of operations that might care about order. I'm not kind of talking about that in this particular example, but yeah, it will preserve order for you 4 times where operations require order. Yeah.
But here it says F and then M for the levels, and then in the data it's not preserved. Is that just because there's only 2 versus 3?
So you're talking about when I type it out here as a factor.
Yeah.
So you can put them in any order this is just the order that I'm specifying, if that makes sense. I'm just saying F first, then females, and then males. It's, yeah.
But just in the data then it's the males first and then the females?
Oh, you're saying why does it show up like this?
Yeah, when the levels are.
Oh. Yep, so there's a, so it's disconnected. The way that it shows the data is totally disconnected from the order levels. So this is showing up in the order that I input the data. And in fact, we can see that in the previous example, like when I returned this is a factor object, it gave it in the order that I originally specified. There's like some dictionary behind the scenes that says, but the like order of these things is actually this. And so you can look at, for example, how do I do this? Order factor 1. It will tell you the order that it got displayed, just based on however I typed it out initially. Yeah. And what you can like reorder things to match the factor, but this is just based on how I input the data. Yeah. yeah, to be clear, this will tell you what the order of the things are. It does not tell you to display them in that order. Yeah. Okay. So finally we get to data frames. This is kind of like the easiest and most common format data structure that we use. It's kind of just a table of data. You can think of this as kind of like, the analogy is like how you would set up the data in like Excel or something, right? So I have like columns and rows, and these are the column names, and then these are, you know, the elements within each of the columns. Okay. All right, so if you'll recall from last class, there were a couple of functions that we looked at right at the end of that function list. I talked about summary, and I talked about structure. So let's take a look at what these functions do when I put in a data frame into them. So these are really helpful functions to quickly grasp some of the high-level information about the data within that data frame. So if I run this, there's a couple things that you can see here. So let's walk through our columns. So there's 5 columns. There's student, ages, gender, math score, verbal score. So the first one to look at are the columns, the numeric columns. So that would be our ages, math score, and verbal score. And hopefully, as you can see, the summary tells us a couple of summary statistics quantitatively. It tells us the min value and the max value of the items in the column. It tells us the first and third quartiles, and then it tells us the median value and the mean of all of the values within that column. Okay, so this is a very standard output. It helps us understand the characteristics and the distribution of the numbered data within our data frame. Okay, we have 2 columns that aren't numbers. Okay, so one of those columns is a character, and one of those columns is a factor. So student, that's the character, and in here it's going to tell us kind of the least useful information. It'll tell us how many elements there are. So there's 3, and it's going to tell us that it's a character, basically. However, on the factor side of things, it will give us counts of the different categories. So there's 1 female and 2 males. And here, F comes first because that was the order that we specified in levels. Okay. If you create a factor and you don't specify the levels, it will default to alphabetical. Okay. Any questions? So structure is another different, higher level kind of viewpoint of the data within our data frame. So here it is telling us the data types or the data structure. So character, numeric, factor. When it's factored, it'll tell us the levels, and then numbers. And it gives, some, there's some visualization of the numbers here, but oftentimes you're dealing with data sets where visualizing this part isn't as useful, right? So I would say structure gives you a quick and easy way to look at the data types and data structures, and then summary gives a good statistical summary of the quantitative data in your data frame. All right. Any questions? Okay, so the next piece of investigation here. Actually, one more thing, just for convenience. If I hit names student data, this will give us the column names of my data frame. All right, so now let's do lookups. Okay, so this is, again, one of the more useful areas to be comfortable with is being able to look at and filter data, right? This looks simple, but it's one of the more powerful tools here to like manipulate data, right? You know, when we think about like editing data in like some kind of like database, you know, if you've ever worked in Excel, right, you have some data, you can go in, you can like manually change things. Imagine that you're working with really, really large data sets, right, where that manual manipulation becomes a lot more time consuming and in many cases just kind of impossible. A lot of the filtering and indexing that we're talking about here are the basic tools that you would be able to leverage to be able to do like data manipulation at a much larger scale. So this stuff will look easy, maybe, but it's definitely one of the more useful things that we can do. Okay, so not to belabor that point, so we've talked about referencing things within that object, right? We followed up with square brackets, and that's the same for a data frame. So, again, going back to this principle of like trying to predict what's going to come out of my code, right? This is good practice. So what's going to get returned here before I run it? The first row, right? So run this, and indeed, it's going to give me the first row of my data frame. This in itself is a data frame, right? It is data frame that just contains one row. And I can do multiple rows, student data 1 to 2, something like this. Hit enter, and that returns the first 2 rows. What about this? Any ideas? Second column, right, I heard. Okay, when I return the second column, am I returning a data frame or am I returning a vector? Yeah, that's right. So, remember that, so this is a, good insight into the structure of the data frame, right? So if you look at this table here, as I go across a row, I can be character, number, factor, number, number, right? And so you cannot really return this, or that wouldn't really be a vector. You could turn it into a vector, but it would all just turn into characters, right? Because vectors have to maintain the same property. But in every column, all of the elements within the column do have the same property. So you can really think of a data frame as a set of vectors that are arranged in columns and squished together, right? But not as rows arranged as vectors and squished together. It is really like independent columns that then come together as a data frame. Okay? And if I wanted to know, for example, the age of the third student, right? You can get much more specific. I can do 3, 2, indicating that I want the third row, second column value, which would return 27. Okay? So far, so good. Data frames have built into them a little bit more capabilities. And so there are different ways to reference certain things. So student data, I can do $student. Okay, so the dollar is an indicator for a different way of doing a reference lookup. And I can put in the names of columns here. Okay. And I hit enter. It will return the column that is named students, and it's going to return that vector, or that column as a vector with student 1, student 2, student 3. Note that the column names are technically characters, right? We saw that with this function call that I mentioned before. But here we don't put quotes around it, and that is like a property that they decided to build in. That can lead to aberrant behavior if you have certain weird things in your columns. So such as, let me do this really quick. Well, okay, I'll just say, if for example, your column has a space in it, so let's imagine that I did something like, let's say that math score looked like this instead. Oops. Then the way that you would reference that, let me just put this in as the example I had before. So the way that you would reference that, if you did this space math score, that wouldn't work because the space kind of breaks it. So if you have anything weird happening in there, you can put, I don't know what the name of this character is. It's the below the tilde, back quote or something. You can use that character to indicate that that whole thing is part of the column name. Okay. When I was first using R, I used to do this type of thing all the time. And then you can actually even reference like the position, or let's say, let's do age. You can do something like this. So the second position of the age column, you could do like so. I think it's more appropriate, yeah, so to do something like this. So remember, we index row column, and then we were usually specifying the number of the row and the number of the column. With a data frame, you can actually specify the name of the column in the column position. So comma age, and this will return, oh, is age not a column? ages. Sorry. So many typos. Ages. Yeah. So you can do something like this. And I can do multiple columns as well. Okay. And this will return. So even though this is a column lookup, note here that it is returning a data frame and not a vector because we're doing multiple vectors, okay? Or multiple columns. And I can reference a specific row as well as a specific column. Like so. Yeah.
So how do you actually do the $sign for math score? You have to use the dot?
Yeah, so I've done it in a good way in the sense that I've named the column in a way that is appropriate. So I would do math.score like this, and that should return just fine. Yeah. Any other questions? Okay, so I can also, right, so these things that I'm returning are pointing to specific like positions in that object. I can rewrite that, the value in that position. So for example, okay, here. In row 2, the verbal score is 620, right? That's the verbal score for student 2. If I wanted to just change that to a different value, I can make an assignment operator pointing to that position and then just assign a new value. If I do this, and now if I look at the data again, it should have changed from 620 to 600. And you can see that happening here. Okay. Any questions? Okay. Now, let's take a look at adding in sort of layers of complexity here. So let's say student data $verbal.score. So what will this return? Help me out here. Yeah, the column of the verbal scores. So 500, 600, 800. Now I can actually apply filters to this to this. Okay, so without running this, what gets returned from here? The logical, so what would this look like?
True, false, false.
Yeah, exactly. So let's say I wanted to, oh, well, okay, we'll start here. So hopefully everyone can see kind of what's going on here. When you test a conditional against a vector, it's going to test every element of that vector against that conditional. So, is 500 less than 510? Yes, so it's true. Is 600 less than 510? No, it's false, and so on. So I can do this kind of neat little thing where if I want to look at, if I want to return certain elements of my column, I can do so by specifying logicals. So I can say true, false, false of the verbal score column, and it will only return the items that are true. Okay? And what this is essentially doing is it's creating the conditions for us to do like powerful filtering operations in our data. So if I do student data $verbal.score, and then I put in this, so in my index lookup, I want to return the things that are of score less than 510 verbal score. This will return only the values where that happens, which is 500. Okay? So let's combine some of this stuff. I want to let me see here. Let's say I wanted to change, let's say I'm a teacher and I feel like, okay, I want to add 10 points to everyone's, I want to add 10 points to everyone's like verbal score who are younger than 25 and scored more than let's say scored more than 620 on their math score, right? So a question like that, I could go in and sort of manually change this, right? And that would be kind of easy enough. But let's suppose we had like a ginormous data set. Let me actually do that real quick. We're gonna change this up a little. I'm gonna get rid of this column. We're gonna do ages, R uniform from 20 to 30 and equals 10, let's say 10,000. Okay. And then gender, we're going to sample I'm not going to bother making it a factor. C M oops, F n equals 10,000, replace equals true, and then we'll do R norm. We'll do R norm 600 with a standard deviation of 100, and we'll do the same here. Hang on. Okay, sorry, I did not prepare this ahead of time. So n equals 10,000, 600, 100, and we'll do the same thing here. N equals 10,000, 600, 100. Okay. Nope. Or you know what, I'm gonna do a sample here. Sample, 20 to 30, n equals 10,000, place equals true. Here we go. Okay. Is it not n? There we go. All right, sorry about that. So now we have 10,000, and I'm saying, let's say I wanted to change the value of everyone's verbal score if they scored above 500 and they're male and they're younger than the age of 25. So how would I do that? So how do I filter for everyone who is, how do I filter for everyone who is younger than the age of 25 in my data? Yes.
I forget what the, it's like, I call it like the blur or something, but I don't actually know what it's called. You could just do the filter.
Okay. Yeah, so, all right. There are packages that will do some of these things a lot, slightly differently, and actually a little bit more efficiently. And right now I'm teaching kind of in the base version, because I guess the principle of knowing is the most important thing, and then adapting that to like other packages, which I do encourage you guys to do, is a matter of like learning the syntax. But yeah, so the idea here that we're trying to get at is that we want to be able to combine multiple filters together. So okay, I'll just show. So student data, dollar ages, for example. Let's say I want to do less than 25. If I want to have that filter in addition to another filter, I can just use the AND operator, right? So this is, if you think about our ANDs and ORs, it is looking for the trues that line up across all of the different categories. So student data, dollar gender, we're saying equals male, and student data dollar math.score less than, what did I say, 650? Or did I say greater than 650? Say something like this. Okay. So this is just a way for us to combine multiple filters together and return all of this. And so if I do this, it'll return basically all of the times that we observe. It'll return the subset of the data frame where all of these conditions are met, right? And so if I look at what's returned here in the console, you should see that all of the ages are below 25, all of the genders are male, and that all of the math scores are above 650. Okay? And that can let us do manipulations in pretty powerful ways. If I wanted to generically just like change all of these people's scores for a particular category, I could do that, right? So if I just copy and paste this, dollar, let's say I wanted to change all of their verbal scores to 1. This will rewrite. I should not have done this. No comma here because that's referring to just a column. That will rewrite all of the data. So if I jump over to here, they will, all of the ones where those categories were met, it would be just equal to 1. Okay. So anyways, you can combine a lot of these things that we were talking about to do some pretty powerful stuff. And I'll just comment back to this question of like dplyr. There are a number of packages in R that work a lot more efficiently and faster than the based version. I'm teaching our foundations in the base version, but you're like more than welcome. And I would encourage you guys to explore other packages. Yeah.
Could you go back to the student tab?
Yes. Here.
So you created a new column?
Yeah, I didn't mean to. I just had a typo.
Oh, but otherwise it would have just replaced.
Yeah. Okay.
Okay.
Yeah. So if I did, okay, let me rerun this. It should have done this,
Okay.
where all of the values.
But you can create a new column that way.
Yeah, you could. You can also create new columns that are based on filters and stuff like that. Yeah. Yes.
How is it like a new file, student data?
Yeah, sorry. So that's one of the nice things about this particular user interface. That's one of the reasons why I kind of suggest using RStudio. It's kind of the most beginner friendly. One of the nice things that it does is if you go into the environment here, you can click on objects and it will bring you to a new tab that lets you visualize it. Yeah, so you can see what it looks like here. You can also actually manually do that in the code and it'll bring it up as well. You use the function called view. Okay. Okay. Do I have time for this? No. Well, I have one last thing to show. We'll start with it next time before we dive into the rest of our data analysis course about merging tables. But we'll cover that at the beginning of class next time. Okay. Any other questions about data frames? Okay, so the basics here hopefully are enough to get you guys started if you're not familiar. Otherwise, hopefully this is kind of a review for you. and maybe clarifying some things if you had if you weren't sure about certain things. But this should be enough to get you started with like the homeworks once that gets assigned. The rest of the quarter, our classes are going to follow a format where I kind of will do more kind of whiteboard work, and then we'll do implementation examples in R. So we will continue to do this sort of format about half the time in class. Okay? Thanks everyone, and see you guys next week.